Good afternoon, good evening. We have a lot to cover today. Yeah. Yep. A lot of things. Good evening, everyone. We're just going to give it another minute and we will kick it off. We will be able to basically continue from the last time where we ended, right? So to give like a little bit of a brief details from the ones that managed to join, they're already aware, but for ones that they did not. So basically, it's a 6 weeks program. Last week was the week one. If for some reason you were unable to attend the last week, but you're looking to get into the materials, please do send us an email over there, and then we will be able. Just make sure that you mention that it's a week one, because last week was the week one. For the rest of the weeks, the other 4 ones apart from today, you can visit our page as well over there. If you are, which I'm pretty sure that you already subscribed, you will get an email for the future ones as well. But all of them are published on our page. To give you an answer, I'm not sure which AI stuff you're meaning for the PCA for the answer for the question over there. But as I mentioned, if you would like to catch up for the last week, just send us an email and we will be able to share the materials from there. Now we have a lot to cover up. Stefan and I today will be your host again and presenters. So we will kick it off. As you remember from last week, we would go through a couple of diagnostic questions with answers. So you will be able to get the feeling. Everything from today, the diagnostic question with answers, the slides, and the homework for the next week, you will be shared via email. So you'll be able to have a look at that. As we mentioned last time as well, please don't enter your emails into the chat, but do send an email to our email that is in the chat, please. So to give you the details, you should have access to Google Skills. If you have registered for this event and it's your first time, you have registered within the last 24 to 48 hours. Please do wait a little until you get access. If you do not have access, again, the email is over there. Now, what I will do right now is I'm going to try to find the appropriate one, from my thousands of tabs, and hopefully you'll be able to see my diagnostic question screen.
Yeah, looks good.
Awesome. Stefan, I am going to leave you to kick off with a couple of diagnostic questions.
Yeah, sounds amazing. Thank you so much for this. And sorry, my voice is a bit not great today. I'm going to try to do my best. Right, so PCA exam guide, section 1, designing and planning a cloud solution architecture. So we do have a couple of points here, just to be aware. But we'll approach this review by looking at the objective of this exam section, and the questions you just answered about each one. We'll introduce an objective, briefly review the answers to the related questions, then talk about where can we find more about learning resources on Google Cloud documentation. As we go through each section objective, use the page in your workbook to mark specific documentation, courses, modules, quests you'll want to emphasize in your study plan. So just going to question number 1. I'm just going to go through the question, and let's say I'll give you 30 seconds, maximum 1 minute, because we do have to cover quite a lot today. And then we will obviously provide the answers, and we're going to look at what's wrong, what's right, why is it wrong, why is it right. Okay, cool. So we do have Symbol Direct, our company. So simple direct drones continuously send data during deliveries. You need to process and analyze the incoming telemetry data. After processing, the data should be retained, but it will only be accessed once every month or two. Your CIO has issued a directive to incorporate managed services wherever is possible. You want a cost-effective solution to process the incoming streams of data. Option number one: ingest data with IoT Core, process with data prep, and store it in a Coldline cloud storage bucket. Ingest the data with IoT Core and then publish to PubSub. Use Dataflow to process the data and store it in a Nearline cloud storage bucket. Ingest the data with IoT Core and then publish to PubSub. Use BigQuery to process the data and store it in standard cloud storage bucket. Or option D, ingest data with IoT Core and then store it with BigQuery. As we have mentioned quite a lot of time, there are keywords in here. So I would essentially, something that has piqued my interest here, as soon as I've read this question, it's your data should be accessed every month or two. And in those possible answers, we do have Nearline. So I would look at this.
Yep. Great thing. Yeah, that's so. For the ones that are probably like were not in our last journey last year for the associate one, whatever we want to try to teach you over here is that when you read the question, basically train yourself to look for the keywords like Stefan mentioned, right? So that's why over here you will see all these questions having some bolded words over there that would be. So like Stefan mentioned, accessed once every month or two, and you have a bolded options over there for a Coldline, Nearline, standard cloud storage bucket, or a BigQuery, right? So that will give you a process of elimination quite fast. But also another one is cost-effective solution. Is it data prep cost-effective, Dataflow, BigQuery, whatever it is? So it will process the incoming stream of data. But if you think about it, for example, let's put it this way: data prep, right? Can you do like something with data prep? Can you do process the incoming stream of data? Like what you can do, or is it Dataflow that you can do? So that's like a little bit of detail, right? So Stefan, what do we do? Do we give them an option for someone to answer in the chat?
Yeah, I think we should do that. And also, in addition to what you just said, I think just pretend we're not giving you the answer to this. I really think that everyone that is doing this with us should look at what does standard, what does Nearline and Coldline means in terms of specific time, because you do have some numbers over there which you do have to remember, because they do have to do with, it does have to do with what's mentioning the question. That's what I wanted to add.
Nice. Let's see if anyone would have an opinion. You don't need to be correct. Don't worry about that, and stuff. We're all learning right now. So
Yeah.
B, like you said.
Ian, it's always...
Yeah. Did you manage to give out the answer? Not really. I think you just probably did it like an example, but that actually happened to be the correct one.
Yeah, that's correct. Because I wanted to focus on the Nearline, Coldline, then standard, because those are important concepts, to be honest with you. Yeah, so the answer is B, Nearline cloud storage bucket. So this is because Dataflow is fully managed service that can be accessed to process both streams and batches of data. And Nearline, it's a good fit because the data could be accessed every month, exactly how the question asked. Right. I think we can move on to the next question. Cool. So customers need to have a good experience when accessing your web application, so they will continue to use your service. You want to define key performance indicators to establish a service level objective. What should you do? Which KPIs could you use? 85% of customers are satisfied users. 85% of requests succeed when aggregated over 1 minute. Low latency for 85 of requests when aggregated over 1 minute, or 85% of requests are successful. I'm not going to give any answer here. I'm not going to say about keywords. You do know what you need to focus on. 30 seconds. Go for it.
Someone says B. Yeah. If you happen to work like with KPIs at work or SLOs and stuff, you would, well, let's put it this way. For SLOs, right, you would need to have something to say like, oh, we have these key performance indicators, so we can establish, well, everyone got it. So I try to do with the keywords and stuff, but yeah, that's true. It is correct because the option B is specific. So when you are specific, for example, 85% of requests succeed when aggregate over 1 minute, and you will be able to measure that, right? But also, not just to be specific and you'll be able to measure it, you also need to, you can basically be reasonable and you will be able to expect to meet this KPI. So that's like another part. Right, awesome. All right, awesome, nice. We go to a couple of more. This is a little bit of a longer one. Stephanie, if you want, I can take it over.
Yeah, go for it.
Awesome, perfect. So Symbol Direct developers have written a new application. Perfect. Did someone actually answer? No. Based on initial usage estimates, you decide to run the application on compute engine instance with 15 gigabytes of RAM and 4 CPUs. These instances store persistent data locally. After application runs for several months, historical data indicates that the application requires 30 gigabytes of RAM. So the management wants you to make adjustments that will minimize costs, right? So one thing to note over here is that on exam, you will have these kind of questions because most likely all of them will be true, but you want to, what you should do, but also do the part, but minimize the cost. So one, it says stop the instance and then use that command and then start the instance again. The command is set machine type with the VMware and to be E2 standard 8. The second one, it says stop the instance and then use set machine type to be a E2 standard 8, but then also set the instance metadata to preemptible true and start it again. What does it mean preemptible right over here? Stop the instance, make the machine type 2 custom for 307720, and then the last one is the same, but start the instance, set the instance metadata to preemptible to be true. What we're thinking, someone thinks to be B, okay? See, persistent data, yeah, a good thinking from Ian, yeah, because they store persistent data locally, right? And preemptible, well, we know about the part of it. So, yeah, so preemptible, they're not appropriate, right? That need to store persistent data locally, and true. See, it is true and stuff, because another part over here is that will minimize cost, right? If I go to the other one, you can see it, minimize cost. And when you are having a custom VMs, it's actually a good way to optimize this cost because you will not pay for any resources that you don't need. For example, E2 standard 8, well, it might not be, the best one over here. It probably will not. We have another one as well that we will do. And then in interest of time, we'll kick it off from this week, but we will send over these ones via email when it comes to that. But cool. So you're creating a new project. You plan to set up a dedicated interconnect between 2 of your data centers in the near future and wants to ensure that the resources are only deployed to the same regions. where your data centers are located. You need to make sure that you don't have any overlapping IP addresses that could cause conflicts when you set up the interconnect. You want to use RFC 1918 Class B address space. So what do? You will create a new project, leave the default network in place, and then use the default 10xx network range. Will you create a new project, delete the default, but set up an auto mode VPC network and use the default 10xx network range? Will you create a new project, delete the default, set up custom mode VPC network, and then use the IP addresses in this 172.16, or you will set up a network in custom mode and use IP addresses in 192.168 address range. But also you would use VPC network peering to connect the zones in the same region to create regional network. What do we think? Someone says C, because of a custom mode VPC. Cool. C. All right, custom mode VPC and 172.16. Is 172.16 Class B address space? Yes, Ian is correct. It is Class B address space, yeah? What is D? D is Class C and 10X is Class A, right? As far as I remember when it comes on that part. Awesome. I think probably don't really need to elaborate further on this part. So what I will do is we will actually switch over to this week, which is module 1. Well, it is module 1 because, as you know, last week was module 0 because we were mainly around the exam and those kind of bits. So, Stefan, over to you.
Yeah, cool. So, as we've been saying pretty much every single time about this, just preparing your for your PCA journey. So in this module, we're going to discuss about designing and planning a cloud solution architecture. We do have a couple of steps in here. Designing Symbol Direct Cloud architecture, which of course Symbol is our company, fictive company. Google Compute Engine and persistent disks, that's very important. Dataproc and Dataflow. So just moving forward with this. I think we did mention this that last week about the 4 official study cases we covered, but in parallel to our 4 official case studies we've covered, there is another one which is not anyhow covered on the exam itself, but it's something that will pop up here and there during each of our sessions to help us make some technical decisions and work on real world problems. So it's nothing critical you should be worried about, but just to be aware that we might cover some aspects of another fake company called Symbol Direct during our meetings. So for this one, we're just gonna move forward. Yeah, so designing Symbol Direct's cloud architecture. So we're just gonna start by exploring the breadth of considerations involved in the design of cloud architecture and the role of PCA at Symbol Direct. Sorry. Cool. So as a professional cloud architect at Symbol Direct, you need to understand that what the existing environment looks like. So each element of the existing environment needs to be either replicated or replaced with an equivalent or better functionality in your cloud solution. So your choices will be based on the availability of the replacement in the Google cloud. And the businesses and technical requirements of the particular migration. So you do see on your screen the existing environment, which I've just mentioned of this just earlier. So Symbol Direct has three major projects: delivery by drone, partner and product APIs, and the social media highlighting service. As part of your assessment, you'll talk to the people who manage the existing environment and learn about this. So just to simplify this a little bit, Simple Direct Delivery by Drone has a website front end, pilot, and track management system, all of which run on Kubernetes. So positional data for drones and tracks is stored in a MongoDB cluster. Drones stream video to virtual machines with stateful connections. Drones are connected to VMs via a stateful connection and stream video via RMTP to the pilots, as well as commands from the pilots to the drone. So for the purchase and product API project, the APIs are built into monolithic apps that are not designed for partner integration. The APIs are running on Ubuntu Linux VMs. And the social media highlighting app is currently a proof of concept. The application currently runs on a single SUS Linux VM. It uses MySQL and Redis and is written in Python. Hopefully you're ready to having some things jump out at you. So for example, what could you use as a potential solution for Redis? You could do a simple lift and shift and run a VM with Redis on it, or maybe would you consider using cloud memory store, clouds managed Redis implementation? So business requirements are critical because they can determine if a solution is acceptable or not. You want to keep business requirements in mind when determining which solutions are appropriate. An organization's business requirements can act as a filter to reduce the number of potential available solutions, making it much easier to determine which is the correct one for the given scenario. So Simple Direct management want to make sure that the company's application can easily scale to handle demand when needed. So the Simple Direct can expand to more test markets. So the what's the requirement here? It's essentially to streamline development for application modernization and new features and products, ensure that developers spend as much time on core businesses functionality as possible without having to worry about scalability whenever possible. Let partner orders directly via API. This is the ideal in every situation pretty much. And get a production ready of the social media highlighting service up and running while ensuring there is no inappropriate content distributed. So moving forward on this one, yeah, sorry, I lost the slide. Much like businesses requirements, technical requirements help you determine which potential solutions would be appropriate for cloud architecture. So you determine that Simple Direct technical requirements are move to manage services whenever possible, ensure that developers can deploy container-based workloads to testing and production environments in a highly scalable environment, standardize on containers where possible, but also let existing virtualization infrastructure to run as it's without as it is without a rewrite, so it can be slowly refactored over time. Securely allow partner integration and allow for streaming of IoT data from drones. You will you will see that this you'll often see that these things can repeat themselves. Business requirements that have similar technical requirements, or the opposite. You'll probably notice that these similarities in Symbols Direct requirements. We're just gonna move forward on this. So we're just gonna look at what's it called? A decision flow diagram next. So Symbol Direct needs to evaluate the potential options for the organization could use to implement a web front end, which is currently running on their on-premises VMs. As a cloud architect, you could use a decision flow diagram to evaluate Compute Engine, App Engine, Cloud Run, and Google Kubernetes Engine to see if they meet the business and technical requirements you have identified. Compute Engine and App Engine both fail to meet the container-based requirement. So in this situation, they are eliminated from consideration. Cloud Run and GKE both meet the requirements of being container-based, streamline development, and scale. But when considering the last requirement of managed service, one choice remains in this example, and that would be Cloud Run. So in this example situation, Cloud Run appears to be the best potential solution, but you will still need to check to see if there are any limiting factors, such as stateful applications, which are not currently supported in Cloud Run. So Symbol Direct has chosen to use GKE initially because it's running on Kubernetes already. However, Symbol Direct is evaluating Cloud Run for the future use, or some of the application would be worth investigating. So there are, again, as we did said in the past, you do need to pay attention and look at the business requirements, look at whatever, whether you have to look at cost, whether you have to look at productivity, and so on. So, yeah, planning for migration and the future. We didn't mention lift and shift or move and improve with different phases: on-premise Kubernetes, Google Kubernetes Engine, or Cloud Run. So after determining the architecture for your solution, you create a migration plan for how Symbol Direct will move its application to Google Cloud. Your role also involves envisioning where Symbol Direct's business may transform in the future and plan how your solution can adapt as business and technical requirements change. For the delivery by drone service, you anticipate addressing potential future improvements by moving to Cloud Run. So next one, we do have a diagnostic question. Sorry. So the diagnostic question sounds like this. You work for a large financial institution that is planning a multi-phase migration of its on-premises workloads to Google Cloud. The migration involves sensitive customer data and requires high availability and disaster recovery capabilities. You want to design a cloud solution architecture that meets these requirements while minimizing costs and ensuring compliance with industry regulation. Yeah, let's go through it. Migrate all workloads to a single region in the Google Cloud to simplify management and reduce latency. Implement basic security measures such as firewalls and intrusion detection system to protect against common threats. Use a combination of managed services and self-managed services to balance cost and flexibility, design a multi-zone architecture with a single region to reduce cost while maintaining high availability, implement measures based on industry best practices, such as strong passwords and multi-factor MFA, use primarily self-managed services to have greater control over the environment, design a multi-region architecture with active, passive, failover for high availability and disaster recovery, implement appropriate security measures such as data encryption at rest and in transit to protect sensitive customer data, use managed service whenever possible to reduce operational overhead and cost. And last option is defer consideration for high availability and disaster recovery until a later phase to minimize initial cost, complexity, implement security measures as needed based on sensitivity of data, use primarily open source tools and technology to minimize licensing costs. Yeah, by the time I finish the actual question, pretty much everyone has provided the answer. Yeah, I can say that right off the bat, option D, in my opinion, it's one of the worst. It feels like you're cutting corners. I just started with the worst one. But yes, option C, it does match the requirements of the question. Well, yeah, I guess it's a question. There's no question mark down there. And yeah, we just want to move to the next question. I guess you nailed this question. Well done. Cool. We have another one. It would have been nice to have diagnostic question. I've got a curiosity. Which answer is correct? Answer A, answer A, answer A, or answer A? Or answer A. You are a professional cloud architect working with a large retail customer that has a monolithic e-commerce application hosted on premises. They are experiencing challenges with scalability and performance, especially during peak shopping seasons. You want to migrate the application to Google Cloud and modernize it to be more resilient, scalable, and cost-effective. Your goal is to design a solution that meets their requirements. Now, what do we think here? Let's just say the first answer, this would be A. Migrate the application on Google Cloud using a phased approach, starting with the lift and shift migration and gradually modernizing concepts. B, which is not here actually, deploy the entire application to a single large compute engine instance to ensure resource availability and minimize management overhead. C, continue running the application on premises and use cloud CDN and cloud load balancing to enhance performance and scalability. Decompose the monolithic application into microservices and leverage managed services like Google Kubernetes and GKE and Cloud SQL. And E, yeah, this is E. Refactor the entire application to serverless architecture using Cloud Run functions and Cloud Run to minimize operational overhead and maximize cost savings. Let's see, very curious here. So we have A, this is A, B, C, D. We're saying A and D, D and E, A and D, A and D, A and D. See, Goran gave you already a hint that we do have first one and fourth one. Yeah, I think almost everyone kind of got the right answer. Yeah, I think we can just show the answer. Amazing. That's perfect. So yeah, well done. I was about to explain this, but pretty much all of you have actually got the right answer. So in the interest of time, we're just going to move to the next slide. So Yeah, I love this kind of animated charts, drawings. I think they look quite good, and they quite helpful when you study. So there are many ways to reach the goal, but how to choose? In short, Cloud Function, if event driven, mostly support STH bigger. If web apps are not containerized, App Engine. If microservices and containers, then GKE or Cloud Run. If more control and flexibility, specific requirements like concrete OS needing GCE. So, as we already mentioned, when working with a public cloud, you could usually make different technical choices. This will allow you to achieve the same goal. Some exam questions will expect you to choose an optimal compute environment to deploy your workloads. And in other words, you will need to choose the optional environment where your application should land, depending on different constraints and requirements. And you'll probably make a different choice if you need to focus on ease of use or event-driven actions or container environments, or if you have some specific OS requirements. So in short, you need to make sure that you do understand pretty much each section of this slide. I think that's pretty much what I can mention about this specifically. You do need to go a bit deeper, and if you don't, it's something that you do not understand, you do have to go slightly deeper and try to understand the particularities of each situation. Okay. Cool. So in next section, we do have the Google Compute Engine, also known AKA GCE. So in this situation, we're going to switch to the main technical topic for the week, which there are Google VMs. From exam perspective, there are one of 3 or 4 services you need to understand very well. So we'll have a look at some details next. Cool. So Google Compute Engine, Infrastructure as Service, IaaS or IaaS, however you want to spell it. So just some basic information about GCE. Be sure to know that you can right size VMs to your needs, but you need to keep some CPU memory ratio, and you can use custom machine only up to some specific size, depending on the machine family you choose. Also, not all type of VMs are available in all regions. Plus, there may be a price difference between regions. I think I've mentioned this thing last week. So you may be asked to optimize the pricing, and one of the answers can be to deploy the VMs in a cheaper region. I've mentioned this US Central 1, Iowa. That's my favorite. Also, be sure to know about persistent disks. So as of today, apart from HDDs and SSDs, I hope you do understand the difference. It's important. Google introduced balanced persistent disks and external persistent disks. So be aware that performance of the disks scales with the size. But since PDs are network attached devices, the performance might be also limited by the numbers of CPUs on the VM. Since network performance also scales with the number of processors. So don't be surprised if you'll get a question about poorly performing storage, when the answers could be resizing disks, but also resizing VM itself. So next thing, when Google says you can resize a disk online, it means that you can increase its size, never shrink it. In order to shrink the disk, you need to migrate the data to another disk, for example, using snapshot. This will also be a valid scenario for changing type of disks, for example, between HDD and a SSD. Quick one about HDD and SSD. HDD stands for hard drive disk, and it actually looks like a disk inside, even though it's a package in a rectangular kind of shape. It's magnetic and reads write, compared to SSD, which is solid state drive, and it would look like a motherboard, but smaller. It would look like RAM memory, let's just say. Feel free to be curious and open one of them just to understand a bit better. Also, try to get comfortable with disk snapshots versus disk image versus machine images. They are a very similar concept, but each of them has some specifics and restrictions. So make sure you do check this one out. We will move for next with Compute Engine and how to differentiate between families. So yes, Goran did said that we will send this, but feel free to take some screenshots if you do want. If you're very eager to actually have a look through this, because it's quite interesting. So VM families overview to help and see how all these use cases that are possible with our different VM families. So use when efficient E2 launches. Sorry, I missed this one. I meant to say something else. Our VM families come in several different types, general purpose and workload optimized. Our general purpose VMs are simple, flexible, and the best fit for most workloads. They are available in either predefined or custom machine types. They offer flexible sizing with the availability to configure CPUs and memory independently. These VMs are great for databases, web applications, mobile gaming, and development or test environments. E2, general purpose. VMs allow you to benefit from deep saving up to 40% of general purpose fleet. These families of VMs is great for customers who do not have an application dependencies on a specific processor. So you simply just pick the amount of CPU and the memory you want, and this essentially will be provisioned. We proactively, so this is proactively adjusts capacity for the entire fleet to optimize utilization. So this means that this will be given whichever processor family is available, and you will essentially save quite a lot. So compute optimized VMs are the best fit for compute intensive workloads, including AA, gaming, EDA, and HPC, that are powered by high-frequency Intel Scalable CPU, Cascade Lake. I have some specific information here, with 3.8 gigahertz or all-core turbo. They offer 40% higher performances compared with other GC VMs. And finally, our memory optimized VMs are best for memory intensive workloads, including in-memory DBS, SAP HANA in memory analytics, and in memory caches. So memory optimized VMs offer the highest gigabytes per core with 15:1 and 25:1 gigabytes per each CPU. They can be configured up to 100 up to 12 terabytes, and yeah, up to 12 terabytes. Next, we will speak about compute engine. Max shapes by machine type. So we do have here, as you notice, and if you have a look on the slide, a kind of comparison, RAM and CPUs, which is quite interesting. So while custom machines offer flexibility, it's important to remember that predefined shapes are often most optimized for standard workloads. If your resource needs perfectly match a predefined ratio, you generally get a better price performance there. Also, keep an eye on extended memory. If you push your RAM to CPU ratio too far, Google adds a surcharge for that extra memory, which can sometimes make a custom machine more expensive than just moving up to a predefined tier. So this one, just to understand it, because when I first look at this, I found it quite difficult to understand it. So we're just going to use an analogy, which I think it's pretty much easy for everyone. It's like one of those pizza that you order from Domino's, and you do have your pepperoni, you do have your carbonara, and so on. But sometimes you do want to, and let's just say pepperoni or carbonara has a specific amount of elements, but you do want to make your own. In this situation, just to use this analogy, if you're choosing to put 50 ingredients, although it's less likely, then definitely your pizza will be quite expensive. So it's sometimes much better to have a predefined tier, as I have just explained on this situation. Okay. So next slide, we're gonna still look at compute engine. I hope this does not look too complicated for you. But there are a couple of interesting aspects to have a look at this. So we're gonna look through categories, if that's okay. So the first category would be essentially the speed boost, tier 1 networking. The second one will be the multiple names, alias IPs. The third one would be the security bridge, multiple NIC, and the fourth one would be the disk, the persistent disks, essentially. So for the first point that I've mentioned, by default, the VM has set a speed limit for sending data. That's good to know. If you choose a powerful machine and turn on tier 1, you essentially unlock a much wider lane of traffic, allowing for much faster data transfers up to 32 GB or more. Alias IPs. A single VM can have more than one internal IP address. This is mostly used for Kubernetes, where you have many containers inside one VM. Containers, I think they're called pods, to be honest with you. Let's just say, for the sake of conversation, we call them containers inside one VM. And each one needs its own unique ID to talk with others. The security bridge, the multi-NIC. You can plug a VM into multiple separate networks at once. The catch here is that each connection must go to a different network. This is how you build firewall VMs that sit between public network and private one. And persistent disks. In Google Cloud, your hard drive, the persistent disk, it's actually connected via network because they share the same wire, let's say. Google intelligently manages the traffic so that your disk performance does not crash just because you're downloading a huge file from the internet. So just a key takeaway here, and we can move forward. Networking on a VM, it's flexible but shared, whether you're scaling up bandwidth with tier 1 or connecting to multiple networks via multi-NIC. Remember that the disk performance and network speeds are linked. So always size your VM CPU correctly to ensure you have enough room for both. Okay. Yes. Metadata server. So every VM on Google Cloud has a metadata server. You can think of this as the VM's internal about me page. So should we care? If we do care, why do we care? So essentially, it's how VM knows its identity, like IP address and which project it lives. It's used for automation. We can inject custom scripts or data into metadata, and the VM can read the data to set itself up to automatically when it starts. It's a security gatekeeper. It manages the SSH keys that allow us to log in, and it handles service accounts so the VM can securely access other Google services without needing hard-coded passwords, which would be wrong. Very important here is that the metadata server is highly secured. So requests to it never leave the physical host where the VM is running, meaning that your instance identity information isn't floating around open network. It's the primary way Google Cloud handles zero trust security for compute instances. And that's pretty much done on this bit. We will move next with the what we have next. Spot, preemptible VMs. Yeah. So for these ones are made for batch, fault tolerant, and high throughput computing. The price tag, you can get those for up to 91% off the standard price. The catch, Google can preempt shut down your VM with only 30 seconds notice. If they need that capacity back from the customer paying full price requirement, your application must be fault tolerant. This means that the VM suddenly dies, your work shouldn't be lost, and it should be able to pick up where it left off on a different machine. So let's talk a bit about the spot VMs. Think of this as standby tickets on a flight. I'm sure you took flights and you've heard of standby tickets and what they do. So you get a massive discount of 91% just because you're using space that Google isn't currently using. Same as your standby ticket. However, just like a standby ticket, this can be bumped off the plane, which, yeah, we've seen on the news that it can happen. So if a full paying customer needs that server, Google gives you a 30-second warning, which is not very much, and shuts your VM down. When should we use them? They are perfect for batch jobs that can be interrupted, like rendering a video, running complex math simulation, or processing huge sets of data. If the machine shuts down, you just restart the job later and save a fortune. Those should not be used when you need something always on. For example, a customer facing website or some really important part of your business, let's say. So that's essentially pretty much on this. We will still be on the compute engine, automate start-stop activities. Start sounds like it's a specific model of a car with a start-stop button. So the goal is here, it's essentially automation. So now we look at how actually to automate the life cycle of our instances using start and shutdown scripts. Instead of logging into every machine manually to install software, we use these scripts to do heavy lifting for us. The moment VM it's born or right before it dies, essentially. So how do they work? Startup scripts. This runs every time the VM boots up. As soon as you see in the code example, we use them to update the OS, install web servers like Apache, and pull in application code automatically. Shutdown scripts, which is looks a bit more simpler, obviously, because shutting down. Those are critical as well. They run right before the instance is terminated. This is your last chance to perform cleanup tasks like moving logs to a permanent bucket or saving the current state of the process so no data it's lost. So on this bit, key limitations. There are a few exam tips and real-world constraints to keep in mind here. These scripts are considered best effort. This means that they usually work, but they aren't 100% guaranteed to finish. So don't rely on them for mission-critical tasks that have no backup plan. So shutdown scripts have a strict time limit. A standard VM gives you 90 seconds to finish your cleanup, but if you're using those spot VMs we just talked about, you only get 30 seconds before the plug is pulled. So you can get the scripts at the individual VM level of the whole project level. Just remember that a script set on a specific VM will always override a general project level script. So general project level script, and we have the specific one. This will be in this will be implemented. This will take effect, essentially. So just a takeaway here. Essentially, these scripts are the secret of operational efficiency. They allow you to stop treating servers as unique manual projects and start treating them as standardized resources. If one instance fails, the system doesn't require a technician to log in and fix it. Instead, a fresh identical instance automatically takes its place. This is essentially a self-healing. It's what makes cloud architecture truly resilient. Next, I think those are your favorites. Actually, we do have some diagnostic questions. So you want to create a number of spotting Linux virtual machine instances using Google Compute Engine. You want to properly shut down your application before the virtual machines are preempted. What should you do? Option A, option A, option A, or option A, or option A. Create a shutdown script named K99 shutdown in that directory. Create a shutdown script registered as X in TD service in Linux and configure a cloud monitoring endpoint to call the service. Create a shutdown script and use it as the value for new metadata entry with key shutdown script in the cloud platform console. you create the new virtual machine instance, create a shutdown script, register as xintd service in Linux, and use the G-Cloud Computer instance. Add metadata command to specify the service URL as the value for new metadata entry with the key shutdown script. Okay, so I see that pretty much. I'll leave you 30 seconds whilst I get a refill of H2O. Okay, so I look through the responses and I see I see one last one. Okay, third one. Yeah, I think we should we do drum rolls? Yes, the third one, it's correct. So creating a shutdown script metadata entry. Why? Yes. This is a standard. It's a built-in to ensure Google Cloud tells the VM exactly what code to run the moment a shutdown signal is received. I see one person that has said last one, option D. I'm just going to mention about this and just move on. So while you can use URL for scripts, option C is more direct and reliable method for local script execution during time-sensitive spot VM termination. That's the explanation for why option D or last one is not working. Okay, cool. Next one, we're gonna speak about compute engine creation. So we do have a couple of informations here that we can speak about. So I want to speak about 4 points here. It's public images, custom images, snapshots versus machine images, and best practices. When you first create a VM, the most common choice is public image. These are provided and maintained by Google or companies like Red Hat or some other companies, let's say. It's like getting a brand new computer with a fresh install of Windows, Linux, whatever you want to put there. It's a clean, secure, and ready for you to configure from scratch. Custom images. As your organization grows, you likely move towards custom images. This is where you take a VM you already configured, install all your security patches, middleware, apps, and bake everything into a new blueprint. So now instead of manually setting up every new server, you can launch 100 identical ones in minutes using your own pre-configured templates. So if you do remember, just a quick add on this, before LLMs, AI, ChatGPT, you would have to actually code everything line by line, which is true. I used to work on websites and I used to have templates and the structure would be identical. I would copy the template and essentially I would start filling up based on the requirement of that specific template. So this is similar situation, which I've mentioned. Just duplicate this and then adjust it to your own needs. Okay, cool. So next point, snapshots versus machine images. So We have snapshots and machine images, which they are more about capturing a specific moment in time. Snapshots are focused on the data. They are great for backing up specific disks before you perform a risky upgrade, for example. Machine images are more holistic. They capture the configuration, the metadata, and all the disks attached to the VM, making them gold standard for full system cloning or disaster recovery. Best practices here. A pro tip for architects: if you decide to go for custom image route, treat it like a software product. Keep them in a dedicated central project so you can control the entire life cycle, versioning them, testing them, and sharing them securely across your whole company rather than having them scattered everywhere. Next one, we do have, what do we have? Diagnostic question again. So you need to deploy an application on Google Cloud that must run on Debian Linux environment. The application requires extensive configuration in order to operate correctly. You want to ensure that you can install Debian distribution updates with minimal manual intervention whenever they become available. Should you create a Compute Engine instance template using the most recent Debian image? Create an instance from this template and install and configure the application as part of the startup script. Repeat this process whenever a new Google Managed Debian image becomes available. Create a Debian-based Compute Engine instance, install and configure application, and use OS patch management to install available updates. Create an instance with latest available Debian image. Connect to the instance via SSH and install and configure the application on the instance. Repeat the process whenever new Google Managed Debian image becomes available. Or the last option would be to create a Docker container with Debian as a base image, install and configure the application as part of the Docker image creation process. Host the container on GKE and restart the container whenever a new update is available. Right. Let's see. Second one, B. B. Yeah. Well done. So, yeah, A is B. This is the most cloud native and automated solution, essentially. It allows Google Cloud to handle the heavy lifting of scanning for updates and applying them across your fleet with minimal manual intervention. So it's easy peasy. Next one, I think, Goran, would you like to... You still with us?
I am, yes.
Sorry, I hope I haven't. I've been bombarding with pretty much quite a lot of information. I know that. I hope our guests are still with us. Do you want to take over?
Yeah, definitely. Thanks very much. So what I will do first is, because it has been actually a lot of information, so I'll give it 2 minutes. If anyone wants to grab a fresh cup of tea, coffee, whatever it is, and we'll be back here. I would say here now is 13 past. So let's give like a 3 minute, 16 past, and we'll kick it off and continue. We have a lot more slides to go through, but for the ones that we won't be able to cover, we'll share it over so you can read it at home. I'll see you here in 3 minutes.
Nice.
Awesome. All right. Hope everyone got their drink and stuff. I know I got mine. And let's continue, right? So we're gonna continue. As you see today, you probably see like a little bit of a pattern, right? So we're talking about compute engine, mainly about VMs and stuff. So when it comes to the exam, right, shielded VMs is actually, well, it's a best practice, it says over there, but it's something you need to be familiar with. So basically, on the exam, to look for is the details that the VM creation, like when you go to the VM creation UI on the Google Cloud Console, when you go to like security, for example, over there, and then when you click the link, you can actually go through there. What's the shielded VMs, and basically just around that. No, so they are one of the best practices, but also they're like the most secure when it comes to like a couple of more details. So if you see over there, secure boot, if you need to have a secure boot, what is the details over there, the results or implications on that side. So if you don't need to have any of the security, virtual TPM, as you know, trusted platform module, that is very important as well on those ones. It is not actually recommended. When it comes to deploying compute engine or VMs on Google Cloud, the recommendation is always, security first. When you go to a little bit of more details, right? So what are the sole tenant nodes? So in short, sole tenant nodes will give us the possibility to fulfill some kind of like a regulatory compliance. So if you have a compliance to have a dedicated hardware, this is something that you will have like a sole tenant node, right? So what it means is that you can run on dedicated hardware. You can have, for example, you need to be aligned with licensing models as well, based on CPUs instead of based on vCPUs. So you're the only customer that will use that dedicated hardware. If you are creating, let's say, like for example, if you think about it, if you create a virtual machine with a Windows operating system and you bring in your license, you need to have some requirement to meet that line, to be compliant with that license, right? If you have in the past dealing with Windows on that side, you probably notice that it's a little bit complicated when you need to calculate all those details. So, right. So there has been like on the exam, there has been like a much more detailed questions on the exam. So you need to kind of like a little bit knowing a little bit more from a technical perspective. It has been on that side just because of the regulatory and compliance. However, just go through it, go to the documentation, you'll be able to find out more on that. Quick start for sole tenants. For example, the only details that you will need to kind of like be aware for this one is you need to understand the provisioning, like the process of provisioning that node group when it comes to this one. So if you see over here, the step one over here is like, oh, you have a node, like your own template, which is like a node group, and you will like create and you will be able to deploy multiple VMs. In addition to that one, as you can see, when you deploy them, when those groups are ready, you need to know as well how to schedule those workflows by seeing over here. So how you will schedule those workflows on specific nodes, how do you schedule those workflows on node groups, how would you do that by using their let's say like their names, their labels, or anything like that. So if you see over here, there's like a couple of commands over there. The most used one and stuff, as you can see, is by node group. So you will be able to create instances by the node group. Apart from all this one, right, you'll be able to deploy VMs by using labeling as well. So that is another part as well that is quite most asked questions, let's put it that way, when it comes to this topic. If we are going kind of like away from the sole tenant nodes, we should discuss a little bit more about managed instant groups, right? So managed instant groups is kind of like, let's put it this way, they are key to auto scaling, right? So when it comes to auto-scaling, managed instance groups are a key. So there's a couple of details over here. We can see over there, like the first one, the auto healing. So the auto healing will detect any unresponsive VM instances, for example, and then that will be some user configured health checks. For example, I don't know, no response about this time and stuff. And after that health check failed, those failed VMs will need to be automatically recreated. So, which means that when it's going to be recreated, that managed instance groups will be brought back to the desired capacity, right, to the number that are needed. When it comes to regional groups, they would increase application availability by spreading, let's say, like that one when it comes to like a multiple zones as well, which will protect them for actually that zonal failure. Dynamically auto-scaling as well is that will add and remove VMs in response to like when you have like increase or decrease in load. This can actually save in the long run, right? But also when your application needs more, then it's also like can be able to offer that as well. Load balancing is one thing as well, which if you see here, like it works with load balancing, but it's something that we will cover in details a little bit later. But it's good to know, right? When we have, let's say, like a lot of emails, so a lot of VMs. This can be between the tens of thousands, hundreds, whatever you want to call it. We need to have a single static IP address that the request will come in and will use that IP address. So this is where load balancing comes in, right? So let's put it this way. When does it make sense to have like a managed instance groups of size 1, right? So when does it wait? When we have like a low load, and anything like that. What is the advantage, let's put it that way, when we have like a vanilla image, but when we use like a startup script or anything like that? So this is something that to think about when it comes to the actual exam. So the actual key benefits when it comes to managed instance groups, right, is that high availability, the scalability, automatic updates, and we have the support for stateful workloads. If we go through the ones that we mentioned, like the workflows and the scalability, there is when it comes to managing Staruba, there can be stateful and stateless. So when it's possible, it's always preferred to use stateless because with stateful, it's much harder to scale down because like it says the name, right? Each VM will keep its state locally. I won't go into more details on this slide. Feel free to like go through it. But when we need to choose an instance group for like, let's say like for our compute engine, we need to have a little kind of like a data. Do we need to be managed, unmanaged? Does it need to be zonal? Does it need to be regional, right? So those are kind of the type of instance group that we need to consider. So put it like this way, right? If we have an unmanaged instance groups, and it will collect, let's say, put it like a different kind of instances. So this will be done for lift and shift or anything like existing designs or anything like that. But if it is not recommended, right, it does not mean that you cannot make the best use of the features available in the cloud. So when it comes to unmanaged, it is not recommended, but it does not mean that it always will be not recommended, right? So for example, we won't have auto scaling, if you can see over there, or unmanaged. There is available on managed. So, however, for some details, it will be actually still be applicable, right, when it comes to that. Regional managed instances, they will be distributing the instance within the zones of one region, and then multiple zones, within the region. And then if we see like over there, the zonal one, well, this will be like within the same zone. So when it comes to the actual exam, the main thing to think about here is that how we can implement new versions of software when using managed instance groups. So you will need a new instance template, and you need to create that new instance template because, for example, you want to edit an existing one. Does GCP or Google Cloud, does it allow you to edit existing templates, or like you need to create a new template because of that? Kind of like I think about those kind of details, right? Because sometimes you will be asked kind of like a, well, thinking about a tricky question, but not really a tricky question, right? Does the I'm thinking out now, does the managed instance groups, right, that have like a functionality that will allow you to roll out a new version? Like let's put it like that, where you want to do a rolling upgrade. Does it have that one? So those are like a couple of others. So when it comes to like a scaling, right? So the couple of details that you will be asked sometimes here is that should you scale based on CPU, or should you scale something on else? Should you include like a cooldown period if your VMs need a while before they're like able to serve requests? How many VMs you should add or remove when it comes to like those auto scaling? Can these, like all of them, like we mentioned now, can all of them be set as parameters, etc., right? So the auto scaling, as we can see over there, right? So we have CPU utilization, we have cloud monitoring metrics that we can use, schedules, which mean like we can schedule auto scaling on those kind of details. So when a new load comes in, right, the autoscaler will add that one. However, but if it is a long initialization time when it comes to those VMs, when those VMs are ready to serve the loads, so if you have those kind of details and let's say like the previous capacity was kept, will you be able to allow the existing VMs to actually serve that spike? Like, will you be able to, serve, go over there before these ones are ready? So just a couple of details to think about that. As you can see today, we have AAA always for an answer, but that we'll make sure to kind of like, go through that for the next time. So let's have diagnostic question. So your company is running its application workloads on Compute Engine, and they have been deployed in production, acceptance, and development. Now, the production is business critical and it's used 24/7, while the acceptance and development are only critical during office hours. So let's put it like 9 to 5, right? Our CFO has asked to optimize these environments to achieve cost savings during idle times. So what you should do, should you create a shell script that would use to change the machine type of development acceptances to a smaller outside of office hours? And then you will schedule that one on one of the production instances to automate the task. Someone says C, right? So, right. Would you use a cloud scheduler to trigger a cloud function that will stop the development and set the environment after office hours and start them just before office hours? Will you deploy the application using managed instance groups and enable auto scaling based on appropriate metrics? And last one, D, would you use regular Compute Engine instances for the production environment and use spot VMs for the acceptance and the development? So someone says B, someone says C, nice. Another one C. If you think about it, right? So A, can we like eliminate directly? Because we say like over there that, oh, we can schedule the shell script on one of the production instances to automate the task, right? But then we say like, well, we're talking about here that production is business critical and it's used 24/7. So can we like eliminate A because it introduces downtime, but also it has shell script, we also have no managed instance groups over there. Is that really like a, cloud approach when it comes to that? So probably we can eliminate A, right? So now we have B, C, and D. Someone mentioned B, but if we say that it's not critical when it comes to the acceptance and development environment, because they're only critical during office hours, but when we say not critical, does not mean that they're not needed at all, right? Because B introduces that, oh, we just basically stop them outside of working hours, but they're critical during working hours, but does not mean that they're not needed outside of working hours. So this is kind of like a play of words that we want to do. So we can eliminate B. So now we have C and D. D, business critical, right? So can we use spot VMs for a business critical? Even though it's acceptance and development environments, business critical, it is during office hours, which means we can't do spot VMs for that one. So it will make sense to be C, right? So it will cost optimize because we will switch from VMs and we will go to manage instant groups and we will do auto scaling on those ones. So awesome, nice one on that one. Now, let's assume now we actually deployed managed instance groups. So we know what we want for ours, we'll deploy it, and we have that optimal setup for our instance group. But when it comes to like cloud, right? Nothing can be static, which means that, well, as the time goes by, we will need to deploy a new version of applications, which means that if you want to deploy a new version of application, we need to handle that rollout. So it can be like, well, is it going to be a new VM templates? How we can roll them out? How can we test on that and stuff like that? So it is critical to know about updating when it comes to that, right? So if we have, well, the automated updates, right? It will be, it will use instant templates, and that will use that optional kind of like a between stateless and stateful configuration to deploy that new version. But this also, when it comes to managing instant groups, also introduces for us, as we see over there, we can perform a canary update as well. And if you want to test new features or like a new upgrades when it comes to that one. So when it comes to the actual side of the backend, let's put it that way, when it comes to updating, managing instant group, GCP will roll out the new version of our template, but also simultaneously will decommission the previous template use. So that is happening in the backend. So you will actually experience no downtime. Now, well, yeah, it's mentioned over here that it's kind of like the most important because we want to have organization policy constraints. If you remember from our last week, right, we talked about IAM and we talked about the actual roles, which tell us like what's the details we can do, but also we're talking about organization policies, which is the constraint for that one. So we have a couple of organization policy constraints that we want to remember to be enforced. So these are mostly about security. So if we look at this one, right, we most likely want to have, oh yeah, perfect, yeah. We want to enforce that shielded VMs, right? So what it says over there, when set to true, requires that all new Compute-NG VMs use shielded disk images with secure boot VTPM and integrity monitoring. So when you would have that on organization policy constraint set to true, which means that, well, you want, when they will be deployed, they must use those one. Something that, if you remember last time we spoke about, it was that we can actually enforce our VMs to be deployed without external IP, right? So we can enforce on that one to be, just because we have, like, for example, our VMs that are running, but that serves application. That application is only internal, might be like identity-aware proxy that you can actually access that one, or, maybe like from your VPN, and it doesn't need to have, whatever it is, it's just routing internally. So this is something to take into consideration. There we are. Define allowed external IPs for VM instances. So which set of compute engine VMs are allowed to use external IP addresses. We still can have, right, those IP addresses for our Bastion hosts that we can use if you want to SSH and RDP to some of them. For example, our IT team will need to do that. Good thing to note as well. So that VM specific topic over here is that cost optimization, right? So first things first, I will let you know this. You do not need to know the exact prices. I do not know. Most likely, I don't know if actually like anyone knows all the pricing and stuff, because pricing on cloud can be done by different things, right? But from that pricing perspective, you want to be able to actually differentiate from different needs. Thanks, Ian. See you next week. So what does it mean is that if you need to cost optimize, how would you cost optimize that one? Like the preemptible VMs is one thing, right? So although we don't know the pricing, like we know like, oh, it saves us like 90% based on the normal price. Yeah, that's fine, right? But we don't know what's the normal price, but we just know it just saves us. So that's like a thing to actually think about over here. Differentiate on those things and be able to make decision based on cost, because a lot of time you will be asked, oh, you have these parts, and what can I do actually in order, what you need to do, you'll be asked on the exam, so that you will be able to deploy it, but being also cost effective. Because as we mentioned, you would have, let's say, like the use cases questions. Those will be tied to a couple of things. Those will be tied to the business requirements, the technical requirement, and executive statement. Business requirements might be, well, you need to save on cost, this and this. Technical requirements will be like, well, it needs to be running this and this. Should be able to update this. Executive statement is, well, this is how it must operate and stuff. So based on those three, and plus what the question asks. So with that in mind, to reduce cost, right, the director of engineering has required all developers to move their development infrastructure resources from on-prem to Google Cloud. These resources go through multiple start-stop events during the day and require state to persist, right? You have been asked to design the process of running the development environment Google Cloud while providing cost visibility to the finance department. Which two steps should you take? Should you use persistent disk to store the state and start to stop the VM as needed, right? Do we do that? Persistent disk. On the other side, it says that requires state to persist, right? Kind of like option, right? Use the auto delete flag on all persistent disk and terminate the VM. Apply VM CPU utilization label and include it in the BigQuery. Use BigQuery billing support and labels to associate cost. Store all state into local SSD and snapshot and terminate the VM. Store all state in Google Cloud Storage, snapshot, and terminate the VM. So let's think about that, right? Use the auto delete flag on all persistent disk and terminate the VM. I'll straight away say that. Does it make sense? That B? No, it's not. C. What are we even questioning over here, right? Like apply VM CPU utilization label and include it in the BigQuery billing report. Okay, so like we will provide a cost or whatever it is, right? But we're requiring to move their development from on-prem to Google Cloud. D. Use BigQuery billing report and labels to associate cost to groups. Oh, okay, something over there, right? E. Local SSDs. Well, when ANF, okay? So we're talking about E, right? Yeah. So local SSDs, one thing to note over here. With local SSDs, data is lost when a VM goes down. But we can, of course, snapshot and stuff, but it's complex solution. F, store all state in Google Cloud Storage, snapshot the persistent disk, and terminate the VM. Okay. some like see like ANF. So A, I would agree. Use persistent disk to store the state, start and stop the VM as needed. But the other one will be, we'll talk about B, no. C does not make sense. Now we have D, E, and F, right? E, it is lost when VM is actually goes down, kind of like complex and stuff. So yeah, A and D, right? Because so we already with A, we already solved the actual ask. We will use persistent disk to store the date and start and stop the VM. So we do that. What is the outstanding thing? The outstanding thing is for us to provide cost visibility to the finance department. How do we provide cost visibility to the finance department? Well, we will use a Google BigQuery billing export and labels to associate cost to the groups. Because F is actually too complex. We store all the state in Google Cloud Storage, we snapshot, and then we terminate. Yeah. And F will not provide finance, correct. Awesome. That is the one. Now, migration. So kind of like the big thing why we're here, right? Because professional cloud architect, mainly it's need to think about, right, is that we will be questioned on a lot of migration, but also we will be required to do migration plans. The details, well, the difference between, let's say, like associate cloud engineer and professional cloud architect is that associate cloud engineer knows how to execute everything and knows the details about that, but professional cloud architect is the one that does technical migration plan. So when we need to migrate workloads to VMs, there's a couple of approaches, right? So the best practice, there's a couple of, but there is some that are best practices. So what does it mean is that when you would have questions on the exam, many times you would be like, oh, what you should do on this by following Google's best practices. So for example, over here, if we see that, oh, migrate for compute engine, right? So there is going to be like a service, right? Because with this service, Google will try to make it easy as much as possible, but it might cost more, and this and that. For example, if you would need to have some VMs, brought into if your applications run on VMs, and then with a minimal effort, VMs on-prem with a minimal effort you want to bring to the cloud, what you would do? Well, you would lift and shift those VMs up there, right? There is, like, for example, lift and shift like for VMware and those kind of details. So from exam perspective, for example, let's say like migrate for compute engine that I mentioned, you don't really need to know a lot of them for those one, but you should know that there are, and that there are Google's best practices when it comes to this. So before we kind of like wrap it up completely, right, with VMs, so there's a couple of tips and tricks over here for persistent disk. A lot of these slides, we don't want to go into details over here, but what does it mean is that there's a couple of links over here that would actually help you when it comes to that. So for example, the last one, you can attach 1 to 24 local SSDs, ephemeral, data is lost, and blah, 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 those kind of things. So local SSDs are not the same as persistent data SSDs. So there's like a little bit of difference over here. Cool. We have 15 minutes left, and we have a couple of more to go through. So you need to host an application on a compute engine instance in a project shared, right, with other teams. You want to prevent the other teams from accidentally causing downtime on that application. So what would you do? Would you use a shielded VM? Would you use a preemptible VM? Use a sole tenant node, or enable deletion protection on one instance? So someone has an answer? I'll give it like a very short, because it's like a kind of like a me reading it probably gave out the answer on this one. But basically you share your computer instance with other teams, and you want to prevent the other teams from causing downtime. What should you do if you want to prevent them from causing downtime? It's not a trick question. And probably that's correct. You want to enable the deletion protection on the instance. Awesome. With the summary slide right over here from the CloudGirl, I think it is cloudgirl.dev. If anyone is interested, there's like a lot of them over there through. We don't need to kind of like go through all these once, but just for you to know is that, yeah, we do have the that you can be kind of like I would go through these ones to best memorize the actual for the stacks. Now, because we went through so many, right, of them and stuff, we're not gonna do this quiz today, like over here, but I just wanted to share this one, is that as part of the, not a homework, but you will be able to get diagnostic questions for home, and you will be able to go through those ones like from today. It's a couple of them, go through them. There's going to be links as well that you can follow. But yeah, those are the details that's going to be from those like the questions right now. Because we're done with VMs, next thing we have is Dataproc. Now, Dataproc is actually very far from VMs if you want to talk about it, right? So Dataproc and Dataflow, both of them. So Dataproc and Dataflow, they play a transformation part, right? When it comes to like data transformation for pipelines or anything like that. And you need to kind of like know to differentiate in between them. So let's help with that one, right? So Dataproc, it's Hadoop or Spark on cloud, right? That's what you need to think about. So Dataproc, so if because Dataproc connected always to Hadoop, right? So basically Cloud Dataproc. So if you have, it's already there on the slide. I want to mention as well, right? That if you have Apache Hadoop, Spark, Pig, or Hive mentioned, then that one will be Dataproc. So if they already use some of those ones, to what you will migrate them to the cloud, it will be going to Dataproc. So Dataproc, it's kind of like, mostly Google managed when it comes to that one. So if you need to modernize, technology or anything like that, usually when we use like Apache Hadoop, it will be very hard to modernize those ones. So that's why most of the time you would just lift and shift those clusters to Dataproc when it comes to that. So there's also the possibility that you will be able to actually deploy Dataproc on VMs. And so the differences over here is that when it comes from like a Google Cloud site, Dataproc is like a different when it comes to like a best practices. So instead of you having this static expensive cluster, Google, right? It's kind of like things like you can define, or you would define your Hadoop jobs, and then you will then schedule them on the Dataproc clusters. So those are like a little behind. Now, that's one thing. The second thing is that in order to kind of like delete that Dataproc cluster, you will need to offload those results somewhere else. So these two best practices is what you should know on that one. And when it comes to Dataproc, Google would like you to use Google Cloud Storage buckets instead of HDFS. Instead of the other one, HBase, instead of HBase, you would want to use Bigtable. And those are like the best practices. Now, if you and also when it comes to running like a sorry, if you want Hadoop, right? For isolation, if you have a dev and prod and staging, when you need to run Hadoop jobs, you might want to run them for isolation on different Dataflow clusters when it comes to GCP. Now, let's put it this way. You need to migrate Hadoop jobs for your company's data science without modifying the underlying infrastructure. You want to minimize cost and infrastructure management efforts. So what would you do? Would you create a Datapro cluster using standard and spot worker instances? Datapro cluster using spot worker only? Manually deploy a Hadoop cluster on Computer Engine using standard, and manually deploy a Hadoop cluster on Computer Engine using spot instances. So what would you do here, right? So, infrastructure management effort, you want to minimize, we can straight away eliminate CND, right? Because you're not going to manually deploy. Now, the next one is like, you want to minimize costs, right? But yeah, yes, correct. Because, good thing, because if you are only using spot or like a preemptible ones, they do not always save costs because they can cause longer job execution, higher job cost, etc., etc. So that's true. It will be that one. It will be fine. A couple of details over here that you can go through at home. Now we go through, so Dataflow. So Dataflow, it's, well, why is Dataflow now different than Dataproc, right? So the actually high level purpose of Dataflow is very similar to Dataproc. But when Dataproc is recommended mostly for migrating those like on-prem Hadoop workflows, Dataflow will be your first choice if you're creating a new ETL pipeline, right? So we need to transform. So we need to have like something more modern, like something like Dataflow is usually connected with Apache Beam. Yes, with Apache Beam, correct. So when it comes to Dataflow, right, the main advantages would be like performance, but also allow us to create that single pipeline which will handle batch, but also stream data. So when you have like those kind of data, right, or you like a stream, batch, so this is like where you come. So Dataflow. So when you will have the streaming data, so when you have like a streaming data coming, and when you want to have your streaming data only processed once, one thing to note is that Dataflow we use PubSub to make sure it happens. So Dataflow actually works together with PubSub, so to deliver that stream analytics solutions. If you see it over here, Dataflow, it is well integrated with like other GCP services. Out of the box, yeah, it does work. Pops up out of the box, yeah, and you can integrate. So if you see it over here, it's basically integrated with any other GCP services. So it can consume that data from different services and write to different kind of like a syncs. So it can, it can be a data source from BigQuery and then write it, with together with PubSub and stuff. So the one thing to remember over here is that while data store, right, does all these transformation and everything, Dataflow, what does this all transformation is that Dataflow, it never stores the data because Dataflow does not have persistence of its own. So it just basically passes data. So one thing to remember about that. There's a template for different use case and stuff. Pipeline graph, if you have a chance, please do. There is a couple of, I think there are also like a free labs as well to go through. They have a lot of, like the pipeline graph is very, very good. It will tell like how it will go through all the data and expand to be able to transform that. any like example architecture for data analytics is just like right over here. So for example, you have real-time events that are coming like via pops up, and they are streaming, basically data is streaming, and then they go via data flow, and they are BigQuery, and then they just like exported whatever it is. So if you see over here, so we need to analyze the data, right? Data flow will get that batch data from cloud storage, or it will get like that streaming pipeline, like when it comes to like from your game server and stuff. It will clean up, it will transfer the data, and it will be like after that, like going out the data in a proper format, and then it will go to BigQuery, where you can kind of like in BigQuery you can directly execute SQL commands, or you can perform analysis or using other tools. One of them, it will be Tableau, for example. So another one as well over here, your company successfully migrated to the cloud and wants to analyze the data stream to optimize operations. So not any existing codes, they're exploring other options. So these options include a mix of batch and stream processing. So mix of batch and stream, right? So I kind of like give it out the answer over here. If you remember the previous slide, mix of batch and stream processing, and they're running some hourly jobs and live processing some data as it comes in. Which technology should they use, right? Dataproc, Dataflow, JKE, or Compute Engine with BigQuery, and that's correct, Dataflow. You have a mixture of batch and stream processing when it comes to that. Dataflow, so when it comes to like the summary like on this one, it's actually, this is what it will conclude our technical these details. Now, one thing to keep in mind, right, if you see like is that there is many others as well, like ETL tools, and then you will probably like be able to learn about them. So it's not just a data flow, when it comes to those sides. This is the optional part, which once you will be able to go through all of them at home, you will see kind of like a reading material, videos, podcasts, deep dives, etc., etc. But however, as we mentioned, the other one is that make sure to enjoy the journey as much as the destination and stuff. And one thing to want to call out as well is, I will add it now in the chat, is that please do make sure to read out the Helicopter Racing League case study before our next meeting. Everything will be shared. Please look out for an email. So once this recorded, we'll process, we'll be able to share everything via email. So that will include the slides from today's session, your kind of like a homework for next week, which is the actual slides we talked about. And let me just share that part. This is the one where you will be able to have answer like your diagnostic question. And the last bit as well, if you have already, I know like some of you already emailed. If you have missed the last one, we will be able to share those one again. It is happening every Tuesday. So the next session will be next Tuesday, 10th of Feb. If you go to our page, which is, I will add it now into the chat. You will see all of them scheduled over there. You already registered to this one, which means that soon you will also receive an email for the next one. You will also receive an email about sharing your thoughts and feedback on this session. Please do let us know on that part how we are doing, and if anything we should improve, or you have any ideas. Ideas are always welcome and stuff. And as we mentioned, the last one, Paolo, please do email us. It's this is the email. And you have not received the slides last time if you have not attended the session. So just registering, it's not enough for the session. You will need to attend the session in order to receive the slides. at the week 6, we will also be able to shuffle out a couple of 50% discount as well for the exam. And yeah, let us know if anything. And perfect. Yeah, I'll see you all next time. And thanks from all of us.
Thank you. Bye.
Bye. Thanks all. Bye-bye.